Hello Matrix and welcome again. Today we are carrying on with functions and we're looking at exponential functions. Now an exponential function, as the name suggests, goes up exponentially. So what I'm going to do is look at the basic exponential function and then we're going to apply it to a question from a past paper, because usually you understand the basics but then you get to the exam question and suddenly you're not sure what to do. So let's look at the basic form. So we've got this y equals a to the x function. So a can be any number. Let's say that it was 2. Well, 2 to the power of 1 would be 2. 2 to the power of 2 would be 4. And so it would go up exponentially. 2 to the power of 0, well, would be 1. And anything to the power of 0 is 1. So we know that our basic exponential function always intercepts at 1. And then we have a hyperbola, because this value, no matter what it is, so say it was negative 100. Well, we know from our exponent laws that a to the minus 100, you could just take that a down and it becomes 1 over a to the 100. And so instead of being a negative number, it's just a very, very small number. So it tends towards 0. So we have this asymptote of y equals 0. Okay, so that's the basic format. Now, what happens when this a is bigger? Well, then it's just steeper. If this a was a half, well, we know that a half is the same as 2 to the minus 1. So effectively, it actually flips. So if a was suddenly a half, it actually flips the other way around. So anything less than 1, a to the power of, because we know like a third times a third is a ninth. Even if it was, say, 8 over 9, well, 8 over 9 times 8 over 9 is 64 over 81. And so it's still getting smaller and smaller. So this would be our y equals a to the, this would be where, let's just say where a is less than 1. Could go this way. Okay, so what else have we got? Well, the minus p shifts it left or right. So it's going to change the y-intercept, but it's not going to change your asymptote, because whether you shift it left or right, it's still going to have this asymptote here. However, when we change the q, well, that's going to shift it. So if I was to say plus 1, it just shifts the graph up 1. And so our asymptote, instead of being y equals 0, would be y equals 1. So let's just maybe just show that. So let's say that q was, so this would be q. Okay, but this is shifted down, so q in this case would be, say, minus 2. Okay, so q can also be up top. It doesn't matter. It's just a downwards or an upward shift. So this is where q is maybe negative, and this upwards would be q positive. So it just shifts it up and down. Okay, so now let's look at an example. So we've got this question with a parabola drawn. And so we see here that it's got the x-axis and it indeed has the asymptote as the x-axis. So this q here is 0, and we see that here because it's h of x equals a to the x. What else have we got? We've got a point on the graph, which allows us to work out what our a is. There's also another line here, d, from d. So there's this line going across, and they tell us that later on that dq is parallel to the y-axis. All right, so let's just look at the first question. We've got, here's the exponential graph. And they want the asymptote of the exponential graph. Well, we know the asymptote is just q. In this case, q is 0. So our asymptote is just y equals 0. Okay, if this had been ax plus 2, our asymptote would have been y equals 2. Determine the coordinates of r. Okay, so they want the x-intercept. Well, we know that the x-intercept, if everything else is fine and dandy, so there's no change in p, there's no p here, we see that it's just x, or anything to the power of 0 is just 1. So our r coordinates, which is the intercept of the graph, is just going to be, well, x is 0 and y is 1. And we could put a to the 0 there and we get 1. So that's fine. 4.3 asks calculate the value of a. Okay, so they want to know a. Well, we've got a point on the graph, 2 and 9. So we can substitute that into the general equation. So what I'm going to do, just because this is an instructional video and you wouldn't normally do this in an exam, such a long way around, but we've got y equals a to the x minus p plus q as the general equation. So y would be 9. A we're not sure of. X is 2. P is 0. Okay. And so 2 minus 0 is just 0. And Q is also 0. So we end up with, I'm going to put it in regardless. Although you wouldn't normally put this whole bit in here because it's not really necessary. But then we get 9 equals a squared. Okay, and 9 we know is 3 squared equals a squared. So we can drop the 2's, and we know that therefore a is equal to 3. Okay, so we now know the equation of the exponential graph. Let's look at D, which says D is a point such, 4.4, D is a point such that DQ is parallel to the y-axis and DP is parallel to the x-axis. Okay, so we've got that and that, so it's just going straight down. And they ask for the length of DP. Okay, so they want this length here. Let's do it in, which color should we do? Yellow. And so we've got this length here. Well, we know that because this goes up, that B will simply represent the value of the x value of D as well. So if we find out what B is, we know the x value here, and we know the x value here is 2. So it'll just be 2 minus whatever B is. So let me just explain that one more time if I went through it too fast. This value Q, because this is parallel to the y-axis, this goes straight up. And so B, whatever B is over here, that x value is the same as the x value of D. So I can just figure out what B is, and that will give me my answer. Well, in order to get B, they told us that Q is a point on the asymptote. So if I substitute in 1 over 81 as y into this general equation, y equals, we've got a to be 3. So let me just write that general equation. I might have confused things with putting the zeros in, but I just wanted to show you that if there was a value, of P and Q, you would just simply use those in and then solve. So we've got y equals 3 to the power of x is the general equation of this particular parabola. Let's just write that in here. And so we know that 1 over 81 is the value of y. And 1 over 81 equals 3 to the x. Now, 81 is 3 to the 4. No, 27 is 3 to the 4. So it's 3, 9, 27. Yeah, it is 3 to the 4. So it's 1 over 3 to the 4. I'm going to do this in a couple of steps. Equals 3 to the x. So this becomes 3 to the minus 4 because the 3 can go to the top. Equals 3 to the x. And so we know x is equal to minus 4. So B is equal to minus 4. So let's just say solve for B. What we're doing is we're solving for B. And so we know then that the length of DP is equal to 2 minus b, which equals 2 minus minus 4, which is 6. Okay, now the second one says 4.5. So the 4.5 is usually the tricky question. And I'm going to do that in light blue. So what have they asked? H of x plus 2 plus k is equal to 0. Okay, so this was our h of x. And they're saying plus 2. So when we say x plus 2, remember x plus 2, what we're doing is if we change it from, so it went from h of x to h of x plus 2. So what does x do? Well, remember from our previous videos that if you make x plus, it shifts the graph backwards, and minus shifts the graph forwards. So plus 2, we're going to shift this graph backwards by 2. And they're saying, where are the roots less than 6? So first of all, what we're doing is we're shifting this graph back by this value here. Now we knew was from b was -4. So basically, we're shifting it backwards by 2. So it's sort of that value here would now be -6. And they're saying that plus k is equal to 0. So the equation will have a root less than -6. Okay, so what is k doing? Well, k is like the q. It's shifting it up and down, right? So the minus p shifts it left and right. We saw that, so it shifted it left because it was positive. The k would shift it up and down. Okay, so at the moment, it hasn't got any roots. So if you would have shifted down, because this tends towards 0, it would suddenly get a root the minute you shifted it down. So in other words, this is the graph here. And as soon as I shift it down, I suddenly get a root. And do you see that it's going all the way to sort of negative infinity? So as soon as I shifted it down, I would have a root that would be less than -6, which is what they want. So I know that k just needs to be, I just need to shift it down. So I know that k must be 4.5. K must be, because k, a downward shift means k must be negative. So k must be less than 0. So that's the first bit. Now, if it shifts it, if I shifted, so here, if I shifted it any further down, so at the moment, like let's say I shifted it down a little bit, down, I would be getting a negative root. But as soon as it went past this point here, I would suddenly have a root of -4. And we know that this value is 1/81. So if I shifted it more than 1/81 downwards, I would have a root of -4. However, we know that this is shifted by 2. So it's actually technically here. So this point is actually here now. And so whatever this value is as soon as I move it more than whatever this value is, this 1/81, I'm going to have a root that is bigger than -6. And we see that because if you move this down here, you get, do you see we get a bigger root. So as soon as this, so let me just draw it in red so you can see. So can you see that I've shifted it down and I'm suddenly getting much bigger roots. But as soon as I get above here, it's fine. Then it's less than -4, or in this case, because we've shifted here, it's less than -6. Okay, so basically what we're saying is, this is a complicated question. I hope I've explained it okay. But k is also going to be, so k must then be greater than 1/81. And it's got to be less than -6. Okay. So it can't be equal to minus 6. So if we put that all into one value, we can put a 0 here, 1 over 81 here, k. And so we know that k is less than 0 but it's bigger than negative 1 over 81. Less than 0. But bigger than 1 over 81. Bigger than minus 1 over 81. Less than 0. And greater than minus 1 over 81. The reason it's minus 1 over 81 is because it's less than 0. And so you can't shift it down by more than minus 1 over 81. Because if you shifted it down by minus 1, or for example, it shifts it far down. And so we don't want it to be minus 1. We want it to be between these two values. So it's actually very small. There's a very small margin where it's got a root between that's less than minus 6. Okay, so tough last question. As I said, look at the video again, and if you didn't understand it the first time. And yeah, I will see you next time. We will be looking at hyperbolas, which I've spelled wrong there. And yeah, if it did help you, find the subscribe button down below, like, share with your friends, all that good stuff, and I'll see you soon.